Dang, you guys have a lot of suggestions. Wow, I was not expecting that. But don't worry, I have heard your pleas for help. And today we're gonna be answering physics questions. Hooray. Hello everybody, I'm Karar, and today we're gonna be doing 25 minutes of FMA problems. Unfortunately not 75, I know lame, but like, unfortunately I don't have that time right now. Well, I was able to do the 75-minute FMA one because I had like a whole day off, but today we're just gonna do 25 minutes, and honestly it's better, right? You guys can't handle like 75 minutes of me talking, come on. No one can, it's like not even possible. Alright, so my mission, should I choose to accept it, is to do as many problems as I can in 25 minutes, and once I start a problem, I have to actually check the answer. So if I start like number 17, I can't say, oh, I'm going to leave it to next time, because don't worry, there's going to be a next time. We're going to finish this FMA and do all 75 minutes of it, but today we're only doing 25. So if I start a problem, gotta finish it. Sound fair? I think it does. Let's get started. Alright, because you guys asked me to do some more recent FMAs, like 2008 is like ancient, that's what, like eons ago. Why do we have to do 2008? So we're doing 2017 today. It's gonna be epic. Let's start our timer and get started. 25 minutes. No internet, that's not nice. Alright, we're gonna do the epic turn off and turn back on strategy. Epic works every time, not gonna lie. Okay, let's get started. Number 1, a motorcycle rides on the vertical walls around the perimeter of a large circular room. The friction coefficient between the motorcycle tiles and the wall is mu. How does the minimum mu needed to prevent the motorcycle from slipping downward change with the motorcycle speed s? Alright. So basically we got a large circular room, not a small circular room, a large circular room, okay? And basically the motorcycle is going wee, 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 wee. Okay, you get the idea. So the motorcycle is going around, right? So basically the friction keeps it from falling down, but the normal force on it is what keeps it in the circle. So like if we have our motorcycle over here, there's the normal force into the middle of the circle, the Fn. And then there's the friction force pulling it up, Fn mu, and then there is mg down. Alright, this does not look sophisticated, let's shrink our size. So basically, what we want to do is we want to find Fn in terms of our speed, which is s. So we know that our centripetal force just has to be mv squared over r. So we basically say Fn, which is our centripetal force, is equal to mv squared over r. So we know that our frictional force is Fn mu, which is mv squared mu over r, which is just equal to mg. So now it wants us to write mu in terms of v. So let's just move v to the other side and we get g. So basically we get v squared equals gr over mu, and then all we gotta do is say that, oh whoops, we're supposed to move v squared to the other side. I'm trolling, wait up. Mu is equal to gr over v squared. So this is, oh well, v is basically the same as s. So it's basically a d, right? Because mu is proportional to 1 over v squared, which is s to the negative 2. Epic. Alrighty, moving on to number 2. A mass m hangs from a massive spring, okay, connected to the roof of a box of mass m. When the box is held stationary, the mass spring system oscillates vertically with the angular frequency omega. If the box is dropped, falls free. What the heck? What is this grammar? FMA, get your act together, come on. If the box is dropped, falls freely under gravity, how will the angular frequency change? Okay, well, okay, so I think this is just like a conceptual thing. It's basically like if you start accelerating the block, right? You're basically putting, wait, let me draw a picture. Let's see. Typically you have a spring, right? And you have a block of mass m. And basically when you start accelerating the box downward, you're basically decreasing the force on the block. So right now it's mg, right? But once you drop the box that the spring's in, then this mg just goes away. But the spring constant is still the same, and we know that angular frequency is equal to root k over m. So neither of these two things changes. So 2 is a, right? Like omega doesn't change, it doesn't matter what force is on it. Alrighty, number 3. A ball of radius r and mass m is magically put inside a thin shell of the same mass and radius 2r. The system is at rest on a horizontal, frictionless surface initially, okay. When the ball is, again, magically released inside the shell, it sloshes around the shell and eventually stops at the bottom of the shell. How far does the shell move from its initial point of contact with the surface? Okay, so this is an easy like center of mass problem. So basically, if there's no external forces, the center of mass of the two objects doesn't change. So basically, we just have to find where the center of mass is in the beginning, and then make it so that the center of mass is the same at the end. The only external force is the normal force, which is upward, so our center of mass might move up and down, but it can't move right or left. Okay, so at the beginning, we got our two boys over here, we got one is R and one's 2R, right? So we basically have one center is there and one center is there. And then if we want to find the center of mass, we basically just connect these two and then draw it in the midpoint. They're the same mass, right? Yeah, so if they're the same mass, you basically take the two center of masses of the individual objects and then find the midpoint of that, and that's the center of mass of the system. Okay, and now after it stops at the bottom of the shell, it looks like this, right? So basically the center is here, the center is here, and the midpoint of that is here. So basically we want the center of masses to have the same x coordinate. So that means that if we find this x coordinate over here, then we know the x coordinate of this whole thing, which is what we're looking to find. We're trying to find the x coordinate of this, which is the same as the x coordinate of the center of mass. So all we gotta do is find this center of mass x coordinate and we're good. So we know that this is r, and then r over 2 is just how much it moves to the left, so yeah. Answer is B. Dang, the first three answers are DAB. Okay, fine, I won't dab. Okay, chill. Number 4. Several identical cars are standing at a red light on a one-lane road, one behind the other with negligible and equal distance between adjacent cars. When the green light comes up, the first car takes off to the right with constant acceleration. The driver in the second car reacts and does the same 0.2 seconds later. Third driver starts moving 0.2 seconds after the second one, and so on. Okay, so they all accelerate until they reach 45 kilometers per hour, and then they move with constant speed. Okay, so how would we do this? Should we just write some equations? Okay, so the first car is going to, let's see. Well, so the first car basically starts speeding up, right? And then after a while, the second car starts speeding up. But the first car is always going to be faster than the second car, faster than or equal to the speed of the second car. So the first car is always just going to be getting farther and farther away from the second car. And then the second is always going to get farther and farther away from the third car, and so on. So over time, the cars are getting farther and farther apart, and we know that the first car had the most time to get away from the second car. So it makes sense that the first car is going to be farther away from the second car, which is going to be slightly closer to the third car, which is going to be slightly closer to the fourth car, and so on. So the one that looks... Oh, wait, I'm trolling. It's asking for... Oh, the order of what happens. Okay, so obviously it starts at 1, right? That's when they're all stopped, they're not doing anything, epic. Okay, and then it goes to 2, like I explained earlier. And then does it go to 3 or does it go to 4? So once they reach a constant velocity, they're not going to be getting closer together. So once they get apart, they're never going to get closer together because the second car is never going to go faster than the first car, so it's never going to catch up. So if we have so much space between the first and second car and the second one, we can't get to the third one because the first and second car can't just suddenly get closer together. So the third one doesn't make sense, so it goes 1, 2, and then 4. 4 is basically once all the cars are moving at constant speed at 45 meters per second. Alrighty, that answer is B. 4B, let's go. Bro, we're continuing our DAB. D-A-B-B. That's it. Alright, number 5. Projectile launching, let's go. Alright, a projectile is launched with speed V0 off the edge of a... Poor projectile. It's already jumping off a cliff? Not okay. Okay, a projectile is launched with speed V0 off the edge of a cliff of height h and an angle theta from the horizontal? Bruh. Air friction is negligible. To maximize the horizontal range of the projectile, theta should satisfy A. 45 degrees less than 90. Okay. We'll read the options later. Let's first solve it because if you read the options first, then it might mess you up later. So let's do this. So the strategy is, let's think about this in 2 parts, right? So we got a cliff, right? And we have the cliff goes here, and we're basically launching the projectile like this. So basically, this part we know how to deal with. That's maximized. The horizontal range of a level projectile is maximized when theta is equal to 45 degrees. So now we just gotta see when the other side is maximized. Well, it's quite clear that this last part of the journey is maximized if theta is equal to 0, right? Well, we know that it's probably less than 45, right? Because we want to increase the last leg of the journey, but we also want to keep our top leg of the journey pretty big. So it's probably going to be C, because the last leg of the journey is increased when you have 0 degrees. But if it's 45 degrees, then you have a pretty small last leg, but you have a maximum this leg. So it probably is somewhere in between there. So we're going to go with C. Alright, in the mobile below, 2 cross beams and 7 supporting strings are all massless. The hanging objects are M1, 400 grams, M2, 200 grams, M4, 500 grams. What is the value of M3 for the system to be in static equilibrium? This looks pretty nasty, not gonna lie. Alright, so let's just write some equations, right? So basically we got that the top rod has M1G and M2G on it. So we got M1G, then we got force 1 on it, F1, we got a force 2 on it, and then we have a M2G. And that's supported by some upward F. Okay, then our bottom one is basically pulled up by these F1 and F2, and it's pulled down by M3G and M4G. So basically we do torque around the top bar, around the point where the top string attaches, then we could just write that F1 times 0.1 plus M1G is just equal to F2 times 0.2, M1G times 0.4, and then plus M2G times 0.5. And on the bottom one, we have to balance the upward forces and the downward forces. So we basically have that F1 plus F2 is equal to M3 plus M4G. Unfortunately, we need one more equation to be able to solve this. So what we're going to do is what are we gonna do? So then if we do torque on the bottom bar around the pivot point of where M3 is, then we can just say that F1 times 0.1 plus F2 times the distance from the pivot point to F2, which is 0.1 plus 0.1 plus 0.2, which is 0.4, is equal to M4G times 0.6. So basically now we have three equations, right? And we have three unknowns. We have M3, F1, and F2. So if we just eliminate stuff, we're able to solve for M3 and we'll be good. So let me just do that real quick. It's just simple algebra, shouldn't be too hard. And we just get that M3 is 0.7, which is 700 grams. Which answer? Let us see. Okay, answer E, very epic. Okay, I just figured out that it's kind of hard to explain all this and do it in 25 minutes, so I guess that's all I got for you today, but don't worry, I got more coming. But let us first check the answer that we got. Alright, 1D. Bro, we missed 2? Holy moly. Okay, we got 3 right. We got 4 right. We got 5 right. And we got 6 right. Pretty epic. Okay, so now let's figure out what we did wrong with 2 and then we're good. Oh, that's so troll. Oh, bruh. Okay, so the outer box also oscillates. Huh. So we have a box of mass M, okay. And then there's a thing in here, K, and there's M. So originally omega is root K over M, okay, we got that. So basically the intuition is when you hold the upper box steady, the only thing that's oscillating is the one mass over there. But when you drop the box, then the big box is also oscillating with the small box. So basically what that means is that there's a big M on one side of the cube and there's a small m on the other side of the cube. And like the way to think about this is that like a wall, like if the big block is getting held steady, it's like a really big mass, right? Like it's not moving at all. But if you let it like move a little bit, it's like as if there's less mass, right? So if you decrease mass over here, your omega goes up and that's why it's B. Epic. Alrighty, hope you guys enjoyed that. Sorry I couldn't do that many problems, but like a lot of these problems were a little bit more bashy and required a little bit more explanation, so I wasn't able to get through that many. Sorry about that. But hope you guys enjoyed. This is what I got. Thank you guys for watching. As always, if you enjoyed the video, leave a like and subscribe for more. Let me know down in the comments if there's ways for me to improve these videos. Like I know that this was not ideal because I wasn't able to get through that many. But thank you guys so much for your suggestions. I really appreciate them. I will try to come out with a couple more physics videos in the future, but thank you guys so much for watching again, and see you guys next time.